going to talk a little bit about MySQL with enterprise storage. Most of my experience is with using NetApp specifically. So everything that I'm going to be talking about, I've pretty much done before with NetApp. But these principles are pretty universal. So you could take these and apply them to some other enterprise storage as well. A little bit of background about me. I started working with MySQL about 10 years ago. I've been programming since '95. Actually learned on QBasic, great place to learn. I've been working with Linux since 1999, and I'm currently with Clear Channel. I'm the director of database operations over there. And a little bit of background, I lead the database team at Clear Channel. Our users generate about 200 million page views a month of all of our websites. We use MySQL as our primary data store for content for our websites, and we probably, looks like I had a bullet point cut off here, but we have many instances of MySQL deployed, and we probably get around, it changes, but we get around, our application generates maybe 15,000 queries per second of some of our most critical databases. So since I'm going to be talking about enterprise storage, anytime I've spoken to anyone about enterprise storage, I'd like to kind of start with some storage basics. And I find that even though, let me back up actually. Let's talk about, what I'm going to talk about is availability, scalability, replication, backup recovery, and a little bit of DR. How you approach storage will greatly affect those things. The first thing is SAN. When you use a SAN, which basically the NetApp is enterprise storage, or whether you use attached storage. I usually use the term local disk. Basically, local disk being you have a server, you've got a bunch of disks that are attached directly to that server, whether they're actually inside it bare metal or it's an additional attached storage device that has another series of disks on it. I've done both. I've run databases with local disk and I've run databases with enterprise storage, and having worked with both, I would never want to go back to attached storage again. And I'll explain some of the reasons why. Of course, when you use a SAN or enterprise storage, you're going to have a lot, your cost factor is going to be much higher. You need a lot more in hardware. You may need somebody to manage it. You may need to have a dedicated storage engineer. You could be leasing one from hosting. Well, that will alleviate some of the costs. But anyway, when you're working with a SAN, you're going to have a lot more costs. In terms of performance and architecture, one of the big things is IOPS versus disk capacity. And I'd like to just mention this really quick without diving too deep into storage, because people often think about storage as well. I have this many terabytes. Why would I want to waste it? It's really all about IOPS and performance, and you get most of your performance based on the number of spindles that you have. A spindle being each disk. So if you have one disk, if you have a single disk, well, you're limited to the performance based on that single disk. There's only so many IOPS you can put out, regardless of whether it's SSD or however many RPMs it spins at. That disk can only put out so much performance. So when you use many disks and you stripe across many different spindles, you get not a little bit, but you get a performance benefit out of that. I mentioned IOPS versus disk capacity because when we say many disks, that means you're kind of burning up some storage. If you have a disk shelf, then say you have 500 gig drives, and you have a database that's only, say, 50 gigs, it may be hard for you to want to take and dedicate 12 different disks that are 500 gigs apiece to a 50 gig database because you feel like you're wasting a lot of space. But like I said, it's all about the number of spindles. So keep that in mind if you're ever thinking about architecting disk space. Another thing that I want to mention that enterprise storage will have is a very hefty cache. We normally talk about disk controllers and battery-backed write caches. A SAN is going to have something that will probably be able to blow that away. That's really important because when you think about your writes, a lot of times your RAID level, people start thinking, well, if you're using something like RAID 5, it's good for reads, but bad for writes. Just keep that write cache in mind, because if you're worried about a RAID 5 or RAID 50 in terms of writes, that big cache you have may alleviate a lot of that. A couple things to think about if you're using a hosting facility and you're leasing storage on SAN. I always try to ask these questions. Are other customers sharing your disks, right? In other words, if you're leasing, however large your storage is on a SAN and they're giving you a LUN, are you the only customer using the disks that are supporting that LUN, or are there other customers on it? If there's other customers on it, you might want to be a little concerned because one, you're probably not going to know anything about who those customers are. And if those customers ever get any kind of a load spike, get heavy demand, you could take a performance hit because those disks are going to be busy doing work for the other customers. Same thing goes along with networking, right? Are you sharing networking with them? If they have SAN networking, what's going on? Are you dedicated? Are you sharing with other customers? They could saturate that network. What's going on with that? So these are a couple things to think about if you're using a shared SAN and you're leasing it rather than having your own. Another thing is having an API or some interface into the SAN to be able to control things like snapshots and clones and whatnot, which I'm going to talk a little bit more about. To me, that's one of the most important things. You want to be able to control it and use the SAN for all these features that are really going to take you above and beyond using attached storage. So what I want to do is I want to talk a little bit about logical volume management. And this is a little bit different than the way storage is normally implemented on the SAN. But I found whenever I'm speaking to anybody about storage, I find it's always better to talk about this. Many of you may already be familiar with LVM. Basically, logical volume management, at its core, it's a way to virtualize storage. I like to look at it as an abstraction layer over your disk. And in technology, we have a habit of building abstraction layers anyway. In applications, we build a database abstraction layer so we don't talk directly to the database. We do the same thing with memory. We don't talk directly to memory, we have virtual memory. So LVM is basically taking that concept and applying it to storage. So I want to talk just a little bit about how this works. And again, I'm talking about traditional Linux LVM here. So basically, if you think about what we're going to do is take a few different disks, and again, we want to virtualize our storage. We're creating an abstraction layer. So we're taking all of our disks and basically putting them into a pool. Don't confuse this with things like RAID levels for striping and mirroring and whatnot. Take that out of the equation for a moment. We're taking our disks, we're putting them together in a pool because, at least according to this diagram here, we have 3 500 gig disks, right? The volumes that we need, we may not need 500 gigs on each of them. If you look up here, let's say we have an application that needs 10 gigs of space for logs, 600 gigs of space for data, and 250 gigs of space for images. Well, one of the problems is, well, what would you do for the 600 gigs of data you need? You can't fit that all on one disk. You want to build something so you fill up one disk and then overflow into another one. The other issue is, do you want to waste space when you only need 10 gigs? You want to dedicate 500 gigs of storage to just 10 gigs? Probably not. So the idea is you could create individual logical volumes that are created size appropriate to what your usage is. Now the other thing is you may be thinking about growth, right? You may think when you're doing capacity planning, you may think, well, your logs are probably going to grow at this rate a year, so we need this much storage. Well, what happens if one of these grows faster or another one grows slower? Now you've got all the storage dedicated in other areas where it would normally be a little harder to reappropriate it if you were using locally attached storage. You've got all these disks here, but you don't need them. You need other disks here. What are you going to do? Buy another locally attached storage array? It gets a little more pricey, a little more difficult to manage. So what we're going to do is take all these disks and put them in a pool. In LVM, it's called a volume group. This changes in enterprise storage. NetApp, for example, calls it an aggregate. I believe 3PAR calls it a CPG. Everybody's calling it something different. But in LVM, it's called a volume group. Then within that volume group, you can create individual logical volumes that are separate. And these logical volumes can be grown, they can be reclaimed, and whatnot. So just to talk a little bit more about this, how this works. VA will stand for volume A. So we're just talking about one volume here. And what we're doing is we're mapping logical blocks to physical blocks. Remember how we had the diagram? We've got a physical block on disk, and we've got these logical blocks. So LB1, logical block 1, PB1, physical block 1. Pretty easy. What starts to happen is we want to take something called a snapshot. A snapshot is basically a static read-only image of the data at a point in time. Just like it sounds, you're taking a snapshot. A clone is a writable, basically a dynamic image. So clones and snapshots are almost the same. The big difference is you can write to a clone, you can't write to a snapshot. One thing to keep in mind, a clone may look like a snapshot if you've got it mounted up read-only. So I want to talk a little bit about creating a snapshot or a clone. We're going to look at that one block, and of course a volume is going to have many blocks, but we're just going to look at one for the moment. We're going to start with logical block 1, which is mapped to physical block 1. And we want to take a snapshot. So what's going to happen is when we take a snapshot, we're not actually really doing anything just yet. We're not copying our data. Really what we're doing is we're creating a logical block that maps back to that same physical block. So what appears is two separate volumes actually are sharing a block under the hood. So that's how a snapshot is created. The way this works, you're probably wondering, well, that's great when you have a static image, right? But what happens when you start changing that parent volume that you created a snapshot of? What happens is in LVM, it uses something called Copyonwrite, often referred to as COW. What that means is it's going to copy the data every time you make a write. And this should help explain it. So we've got our parent volume in the upper left, volume A. Somebody writes something to volume A. As soon as that write happens, volume B, it's a snapshot. We want to see what it looked like at that point in time. Of course, we don't want it to change. So under the hood in LVM, that physical block 1, Copyonwrite, gets copied to create a second physical block. So this is why over time, as your data is changing, a snapshot will grow. Does that kind of make sense? Okay, good. So the same thing applies for a clone. So basically there's two sides to this. We have the parent volume on the upper left. We have the snapshot or the child volume on the right. When you're dealing with a snapshot, the writes all happen to the parent. When you're dealing with a clone, the writes could happen to either side, right? So I have a write marked on the upper left. If this is a clone and not a snapshot, volume B would actually also trigger the copy if the write is written to the clone. So just a little note, looks like we're losing some stuff here. It's cut off. LVM don't actually use blocks. I don't want to talk too much about LVM. LVMs actually use an extent size. It's actually getting cut off on the bottom here. File systems use a block size. When we're talking about RAID, we use stripe size. And LVM actually uses something called an extent, which is being lost here, but that's okay. A little bit more information, if anyone's curious. Linux LVM2 is actually based on Device Mapper, which is also the foundation for Linux software RAID, file system encryption, and a little bit more. One thing about LVM2 is we're not really talking about LVM2 when we talk about enterprise storage, but I find it's a great introduction to it. These concepts are really important to have. One of the big differences with LVM2, and I don't know if any of this has changed, but at least the last time I took a look at it, there was no way to restore. We can create snapshots, we could create clones, but there's no way to revert back to one of them. And there is also more of a performance penalty in LVM2 than you're going to find on a SAN or any enterprise storage. So I want to talk a little bit about backing up MySQL, and I may have to bail out of this to change the font size because we're cutting some off. When we talk about MySQL backups, there's a couple different kinds. There's online, there's offline. Online, of course, if the server's running. Offline, if the server's stopped. Physical versus logical. Physical backup is basically going in and copying all your files on disk. Logical will be running something like a MySQL dump and exporting all of it. A MySQL dump, one note about a MySQL dump, great for portability. You have all the raw DML statements, DML and DDL. You can take that wherever you want, source it back in. One of the problems with a MySQL dump is it's bad for fast recovery. It takes a lot of time. You got to rebuild all your indexes, got to source all your data in. It's also sequential. That's going to take a while. So everything that we're going to be talking about now is going to be online physical, right? We don't want to shut the server down, of course. We want to be able to take a backup while it's running. So like I just mentioned, a MySQL dump is sequential. It's going through each table one at a time. It's also not globally atomic. In other words, if you think about your entire database, if it goes through each table alphabetically, let's say you have a table, you've got 26 tables, letters A through Z, it's going to start on A and work its way down. Well, if you're on table C and somebody came back in and made a write to table C, you're still making a copy of table C, and you've got a long way to go. So in terms of your entire database, it's not going to be atomic, unless, of course, you try to build something to dump them all out at once. Another problem, too, is if you use MySQL dump, you're going to hold some locks, right? Especially problematic if you're using MyISAM tables. You could cause a lot of issues holding those locks open. Long-running processes, yeah, same thing. If you have a very large data set, it could take a while to run. Same thing, could take a long time to restore. If it's really big, take a very large dump file, it's going to take a long time to bring that back in. A file system copy could become impractical if you have a large data set. In other words, if you have a 100 gig database, it's going to take a long time to copy all that stuff out. It's also going to take a long time to copy it back in. Same thing, if you're trying to do an online copy, it's going to be even harder to do it because you don't want to shut the server down while you're copying that stuff off. So that's going to be challenging. So while you're working on that, one of the things I was saying is a very large data set. Doing a file copy is pretty impractical because, again, your data might be changing. If you can quiesce the database, you don't want to hold the quiesce for long enough to copy all your data out. So one of the great things about a snapshot is they are very, very quick. Because remember, when you take a snapshot, you're not actually copying any data yet. It's almost instant. So if we're able to take a snapshot, it's extremely fast. One of the things that's also important is when we take a snapshot, you want to make sure that we quiesce the database. We don't want to take a snapshot while data is changing, while things are in the middle of being written to. There could still be dirty pages that need to be flushed to disk. We need to address and deal with all that. I'm going to talk more about quiescing the database in a moment. I don't remember what my bullet point after that was.
This one?
Yeah.
You just have a new logical volume that's pointing to this same real data.
Mm-hmm.
It's not really a backup. I mean, if you have a drive failure or something.
I'm going to talk about that.
Okay. So is it just the first step in a backup?
Yeah, actually,
okay.
you're one bullet point ahead. So thanks. So another thing about snapshots is because they're so quick, you can change your approach to backups, right? Where normally you might be taking a backup maybe once a day, once a week, whatever it is, it depends on the application. You can change your entire approach and how often you want to take a backup. I have actually had production systems that take full backups as often as every hour. And it sounds crazy to some people, but I'm going to talk more about point-in-time recovery soon. One of the reasons for it is the more time between your backups, if you have to do a point-in-time recovery, the more time it's going to take to recover that. So when you use enterprise storage-based backup, it's fast, there's very little overhead, you can take those backups very, very quickly and very often. So you were just asking about disk failures and whatnot. Well, one of the things that you want to try to do is take your backups, make a copy on another medium. So if you're using enterprise storage, there's going to be a lot of redundancy. NetApp uses, I think, out of the box, they call it RAID DP. And it's, if I understand right, it's a hybrid of RAID 6 and RAID 4. So you have two dedicated paired disks. And it's also my understanding they're the only ones that were ever able to really perfect that without a major performance impact. So there is a lot of redundancy, and if you are using if you're using enterprise storage, I know NetApp does this, for example. They actually have something built in, they call it phone home. So if you have a disk that fails, they know about it, there's a guy on his way with a new disk. So there's a lot of redundancies. And there's also a lot of things that you can do. I'm not a storage engineer, but there are a lot of things that you can do with replication to other filers and whatnot. So there's a lot of things you can do to prevent against that. But the important thing is if you're taking your backups based on a snapshot, you want them to be readily available so that you can restore from a backup quickly, right? I mean, what would be worse than you need to restore from a backup? It's going to take you 8 hours to copy all the data and get it in place and process it. You want to be able to do it quick. So again, transfer backups to another medium. Quiescing MySQL. So I'm going to start at the top, green, initiate backup, and I'm going to go through this piece by piece and explain everything. And this is actually a process that I've used and has worked very well. So first thing we do when we kick off our backup, we want to connect to MySQL. We want to check and find out what the dirty page percentage is and throw it into a variable somewhere because we're going to need to know that later to put it back. Then what I've done is take that dirty page percentage and set it to 0. And what this is going to do is it's going to take MySQL, or InnoDB specifically, and force it to become I/O bound. It's going to start taking all those dirty pages and start flushing them down the disk. We want to make MySQL a little I/O bound so that we can quiesce it and take a snapshot. So we're now flushing everything down to disk. We're going to set our session timeout. Our session timeout, I'll talk a little bit more in about a second. It's sort of an insurance policy. So basically, by setting the session timeout, this global lock that's about 2 steps down, it prevents that global lock from kind of going awry. Call lock monitor, I'm going to come back to that. Acquire global lock, that's basically a flush tables of 3 lock. So basically what we're doing is we're saying nobody can lock in, nobody can obtain any locks on the table until I free up. There's a problem though with that. So if you execute a flush tables of 3 lock, and you're waiting and you're trying to obtain a lock. As soon as you do that, you are blocking every other process. So anybody that comes in and is trying to get a lock on a table, they're now waiting in a queue. You may not even have a lock yet. You might be waiting for it yourself. There could be another process that's holding a lock on a table and you're waiting for it. So that is the reason for the lock monitor, right? You could actually end up in a situation where you cause an outage and you have resource starvation, drive your server up to MaxCon because you're waiting so long for that lock, it never becomes free. And you have all these connections coming in, trying to write to tables, trying to do something, and they're sitting there in the queue, and before you know it, you're at MaxCon, and you can't take any more connections. So the lock monitor will actually help prevent that. What the lock monitor does is as soon as you call it, first thing it does, goes to sleep for a predetermined length of time. Goes to sleep, wakes up, whatever you decide you want that to be, 10 seconds, 5 seconds, 30 seconds, you can configure that. Goes to sleep, wakes up, and what it does is it looks in the process list and it checks to see, do we have a lock, not a hanging lock, but are we still waiting for that global lock from the flush tables of the read lock? In other words, we had X number of seconds, was that lock fulfilled within that time? If it wasn't, it's gonna kill it and dump out. If it's not running, it's gonna dump out no matter what. That lock monitor is an insurance policy. So after we've got the lock, the next thing we wanna do is check the dirty pages. I'm gonna start looking at the show InnoDB status, or I think it's actually show engine InnoDB status now, and find out how many dirty pages we have. So have a process that runs, checks the dirty pages. Are we flushed to 0? What do we have? If they are not all flushed, basically a loop. It's going to go back to sleep. Keep checking this. You don't want to do this infinitely either. There should be some sort of a timeout in here, a threshold. So dirty pages or timeout. You want to configure how many times can you go through this process before you bail. You also cannot fully 100% quiesce it. I think there's at least 1 or 2 background threads that you have no control over. They're going to do what they want to do. So let's say we have all of our dirty pages flushed. The next thing that we would want to do is capture the binary log, show master status. We want to capture the binary log file name and the position and write that to a text file. Will come in really handy later. The other thing that I've found is very valuable is to capture the process list. And it's something that you will probably not need very often, but if you ever have an issue where you're experiencing some issue around the time of backups, having a process list to see what exactly is running at the moment you take your backup will be very valuable. So it's worth putting it in there. The bin log position and file name, by the way, I haven't rotated them, but some people might prefer that every time you take a backup, let's just rotate to a new bin log file to make things easy. If we had to do a point-in-time recovery, this way we don't have to find the file, find the position, just start fresh at a new one. It's kind of everybody's preference, which one you would like. Once you've grabbed that data, take the snapshot, super quick. We're talking about taking the snapshot. I said set session timeout is kind of another insurance policy. The session timeout is your insurance policy against something going wrong when you try to take that snapshot and it taking too long. Let's just say for whatever reason you tell your storage, all right, take my snapshot, and for whatever reason, that's hanging for a minute. Well, you've got all these locks. If your snapshot is hanging, same thing. You might end up causing an outage because you're going to drive your connections up to MaxCon. So the session timeout is an insurance policy against that. So the process that's doing all this, you might want to set that to 30 seconds, 10 seconds. It just depends on your application. How long are you willing to wait for that snapshot, for this whole process to happen before you drop it? And of course, that global lock, the flush tables with read lock, as soon as you drop your session, that lock is free. So by setting the session wait timeout, that's creating your insurance policy. Snapshots taken, release the global lock, restore the dirty page percentage. That's why we put it in a variable before, so you can put it back together. One thing that I've also found is very valuable, to take all these little values that we're talking about here, session timeout, sleep time for dirty pages, whether it's a second, whatever it is, how many iterations you can go through. Those things are pretty valuable to put them in a config file. Right? If you have many MySQL instances deployed, you may want to tune your backup process differently for each of them. So rather than having to go through all these different files and modify them, throw them in a config file. Makes it a lot easier. You can tune each of them individually.
Question.
Yeah.
For our MySQL installation, we take an hourly backup, and once in a while, when we have to restore from the snapshot, Sometimes it turns out the database does not come up.
Do you have an idea why?
well. Sometimes the table gets corrupt. For
How
some
are you-
reason it doesn't come up clean.
How are
I think
you
it's-
how are you taking the snapshot? Are you quiescing first if a process has quiescing in the
That's my
database,
next
or it's just flying into the backup?
That's my next question. I'm a DBA, and
Mhm.
then my system admins do that, the snapshotting.
Okay.
Is that the
So you
sort
said
of
you're working with NetApp, right?
Yeah.
So NetApp will do a they call it auto snap, where you can set up some sort of retention policy, and you'll have your it'll automatically take snapshots for you, right? But great for a regular file system, you know, if you got images or you know, the rest of your application. Really bad for a database, because the problem is, I mean, I guess it's fine if it's a database that probably never changes or nobody's touching, but if it's a database that actually has transactions running on it, you don't want to take that snapshot of the database while it's doing something, because it's not being quiesced, and that's why you would have the problem restoring.
That's what I think is happening. Is that a sort of part of the standard routine that's sort of available to our
I put this together. Somebody may have put something like it out there, but this actually, the code that ran all this, literally it would be a shell script that runs as a cron job, and literally the code that runs this, maybe the process that I wrote was 15 lines long. Not very long.
And people were doing similar stuff with Oracle databases and apps and other stuff before. The overall, this procedure, the quiesce, snapshot, and then, you know, bring the database back to life, right? That concept's been around for a good long time. Implemented with MySQL, it's probably still been a decent.
Yeah, and the great thing is it's so fast.
Right.
Yeah.
I mean, it is fast, but it is important that it comes up. So
Well, it needs to be, I think, if, it sounds like your problem is the synchronization.
So-
If the snapshot isn't synchronized, right, then you're at risk.
Yeah, I'm gonna talk about something in a moment too that may help you a little bit more, because I'm only really going after backup right now. I haven't even gotten to recovery yet.
Are these SQL commands like creating a global lock?
Flush tables is read lock is. Flush tables is read lock. I think I said show engine NODB status, show master status for the master bin log position and file name. I think that was all I said.
You're
Oh,
making
set
it-
session wait timeout equals whatever you want to set it to.
And what was the read status one again?
Which one?
The read status, what did you call it?
Flush tables.
Yeah.
Flush tables read lock.
Read log.
Yeah.
Okay.
So global lock. So, talking about recovery, reverting to a backup, when you're using snapshots for backups, reverting to a snapshot cannot be undone. Once you've restored from a snapshot, that's it, you did it. You better make sure you really wanted to do it before you do it, because you can't go back. Another thing to mention too is when you recover and when you restore to a snapshot, any future snapshots are gone. You've lost them, same thing. So if you take a snapshot or a backup, say it's every hour, every day, whatever the case may be, whatever that frequency is, if you go back more than one and you restore from more than one, everything in the future is gone. Now maybe some storage providers have come up with ways to get around that, but at least in my experience, that's it. Anything in the future is lost. I put a little diagram together, and it didn't come out quite right. Those arrows were supposed to be straight. But a good way to think about this is as a timeline. And all of the green dots are backups. Whatever the frequency is of them, it doesn't really make a difference. So we've got all these backups, and then, hey, look at that. Some disaster happens. What it is doesn't really matter. It could be a system crash. It could be a security breach. It could be an application bug. It doesn't really matter what it is. Something happens. But the point here is, it didn't just happen. It happened several backups ago. And for whatever reason, we either didn't know about it or didn't realize the severity. So the point is, we have to go back multiple backups. So the backup that we need to restore from, highlighted in yellow, is the one that happened right before the event. So what happens is, we want to restore from that backup, and by restoring, again, this was supposed to be a nicer line, we're basically creating a new timeline, right? We're erasing the future, so to speak. So everything in the future is gone, and I don't know if this will work. Not quite. That was supposed to be dimmed out a little bit. Basically, what has happened is everything up here, the event that happened, the additional backups, they are gone. They're basically erased from history. I know that sounds kind of crazy, but sometimes when I explain this to people, I usually say that the best way to understand this is go watch the Back to the Future movies. It literally is almost exactly what we're talking about here. And again, I'm not even talking about point-in-time recovery here. Let's forget point-in-time recovery and replaying bin logs. Let's just say that we're rolling straight back to that one backup. Everything in front of it is gone. So if you go from this one, from your current moment in time, you restore from that backup highlighted in yellow, all the backups in front of that, or that happened afterwards, they are gone.
What if it turns out that actually the disaster happened right before that backup?
Then you can keep going back. You can keep. I would suggest if you ended up in this situation and you weren't really sure, make sure you're sure, because every time you go back, you're going to lose everything in front. If you needed to iterate and go back one at a time, you could certainly do that.
Sometimes you get MySQL inject hacking and the table gets corrupted, all messed up. You have to go back in time, but then we don't want to go back so much that we lose that good data.
I'm going to talk about something too in a moment if you're dealing with recovering individual tables. See if I can get out of here.
I guess the other thing, that's a good argument for having an efficient snapshot system. Right? So if you can do your snapshots quickly, you can do them every hour, so your risk is minimized.
Yeah, I think I'm missing a few things here. Can I get you to help me again? Thanks. I won't touch it this time.
So you did show the flow chart for quiescing the database, but primarily it's the flush tables with the.
Well, it depends. If you're not using InnoDB and you're just using MySAM,
I think everybody's using.
I would probably hope so. But again, it depends on the kind of data you have. If it's pretty much read only, no one's changing it. You might not. But yeah, flush tables with read log. But then you want to watch the dirty pages as well, because you've got all these pages sitting in memory of data that have not been flushed to disk yet.
How is that taken care of?
You wait. Basically, what you can do is you can ask it. You show engine InnoDB status, and you can see how many dirty pages do we have. And one of the things that we're doing to push that stuff down to disk is by setting the dirty page percentage to 0. You're basically telling the server you're not allowed to hold anything dirty in memory, right? Just start flushing everything down as fast as you can.
Now, Linux has a command flush.
This is separate. We're just talking about MySQL.
But I think doesn't flush actually flush your
It flushes the file system buffer.
yeah, the file system.
But the database may have not written everything out to memory. Right?
Yeah,
I mean,
exactly.
written out to the file system.
Yep. So that's why you want to tell the database, start pushing that stuff down. It's like we're getting ready to do a backup. Make yourself I/O bound.
Can
What's
you
that?
tell it or just watch it with this?
Well, you're telling it not to take it on by acquiring that global lock. You're not allowing any more changes to come in. So that's really the way you do it. You're slowing things down. Nobody else can do anything. I'm holding my lock. You're basically holding back the floodgates. Let it get quiet for a moment. You're also changing, like I said, the dirty page percentage. You start forcing it to start pushing that stuff down to disk. There is also another parameter that you could play around with, and I forget what it is off the top of my head. It might have something to do with, don't remember if it has to do with the adaptive hash for InnoDB. I'd have to look it up, but there's some other parameters you can play around with too. But backups, of course, are only as good as your recovery plan. Backup doesn't do any good if you got no way to restore it. So we were just talking about future backups are lost. One of the great things about using a snapshot, like we were just saying, is the speed. You can recover very, very quickly. It's near instant recovery. There's no need to copy data files. If you're doing something else and you're copying off to another system, you have to copy all that data back. That's why I used the example before. I mean, do you really want to have to copy for 6 hours if you have a huge database to copy all your data and put it back and get it in place? It's going to take you a while. So, source their dump file. Again, if you're compressing your backups, you have to uncompress them. All these things take time. So another thing to think about is if you're running replication, and I'm going to talk more about replication in a moment too. If you're running replication and you have to recover the master from a backup, now your slaves are totally out of sync with your master, and your slaves need to be resynced to the master. So point-in-time recovery, there's a couple different approaches to this. You can either do this, you can either automate it, have some system where you just kind of drop in the starting time or end time. You could build yourself a little abstraction layer, so to speak, around MySQL bin log that sources the data in for you. Personally, I like to do it manually, because I think you have more control, and it also depends on why you're recovering from backup. Was it a crash? Do you truly want to just recover everything in the bin logs, or did you have a security breach? Did you have, you mentioned SQL injection. Did you have something happen where there is a specific transaction that you want to record, where you want to recover everything up to that point? So you may want to, if you're using statement-based binary logging, you may want to go through your bin logs, find that exact transaction, and recover everything up into that point. So just to switch gears again and go to talk about file system architecture. Can I bug you again? It's the same thing. There's a couple different approaches, and I've kind of coined the terms isolated versus unified with your binary logs. So basically, we'll start with unified. With a unified approach, you basically have your MySQL data directory, and then you have your binary logs, and you're putting them all in one thing, whether you're actually running it over NFS, iSCSI, however you're doing it, doesn't really matter. They're all in one place together. Another approach would be to separate your data directory from your binary logs. There's pros and cons to each method. We'll talk about isolated first here. If you isolate the two of them, when you're recovering from a backup, you might only want to recover your data directory. You don't necessarily need to recover your log files. There's some convenience in that because you don't have to copy them out, right? If you recover from a snapshot, all your binary logs are going to get blown away. So by putting them in their own separate volume, when you roll back your primary data directory, you don't have to do anything with your log files. They're sitting there, they're ready to go. All you have to do is source them back in. Basically, that makes your recovery process a little bit simpler. But one thing to note is it's going to duplicate your transactions. If you have to do a point-in-time recovery, because you're isolating your binary logs, your master.info file, all that's sitting separate, when you go and you do this restoration and roll your data directory back, when you source your binary logs back in, you're basically rewriting binary logs in the same place. So you're not rolling back your bin log position. Thanks, by the way. You're not rolling back your binary log position. They're going to keep going. And I've never tried this, but you could actually get into a little bit of a loop, right? Because if you don't put an end time or an ending position, it's going to keep going and cycling through as you're trying to do a point-in-time recovery. So as far as replication goes, your slaves would maintain the same bin log file and position because you're doing a recovery, but they don't change. They're staying exactly where they were. A unified approach basically means you just take everything and put it in one big directory. Again, whatever you want to name these directories, it doesn't really matter. But what this would mean is when you do a rollback or you restore your snapshot in a unified approach, all of your binary logs are going to get wiped out. So if you don't remember to take your log files and copy them out first, you can't do a point-in-time recovery because all that data is going to be gone. Remember, you can't roll forward, you can only roll back. So a unified approach is a little bit more complicated just because you have to remember, right? If it's 3 o'clock in the morning and a DBA has to go and do this, it's kind of a bad time to have to remember, did I remember to copy my binary logs out? But at the same time, you could make it very clear your rollback process. When somebody goes to actually execute the process, do a rollback, the way mine works is it literally asks you like 3 times, are you sure you want to do this? Did you remember to copy your bin logs? Remember to do this? When you're done, do this. 3 a.m. friendly. So that said, I prefer the unified way of doing it. I prefer to put everything in one place. I find it's a little bit easier. Again, it makes it a little bit more complicated, but I think you have more control. Another thing is replication, any slaves, it will fail. Because remember, your slaves are replicating from a binary log file and position that no longer exists. You basically went back in time and you changed the future, and that log they're reading from, it's gone. So replication to slaves will fail. Granular recovery. This is one of the reasons why I started doing this process. I know MySQL and NetApp as well, they both offer their own solutions to backup and recovery that are based on snapshots. One of the reasons why I didn't ever really like them, and again, these may have changed since then, is I wanted and needed much more granular recovery. I needed to be able to go, you mentioned a table, I need to be able to go back and recover an individual table and actually go even further. I need to be able to go into a backup and recover an individual row. So one of the things that I put together is a system to do granular recovery, and a good way of doing this is to create a dedicated recovery host. So we have all these snapshots, create another host, doesn't could be a VM or whatever you want to do. A dedicated host, and all it does is mount up your snapshots and fire up an instance of MySQL on it. Basically, it takes your backup and gives you the ability to go into it and actually query it and bring the backup online. One quick thing to, you probably see, create a clone of a snap. MySQL needs a read-write file system. You can't start MySQL if the file system's read-only. So you can create a clone of a snapshot. And by doing that, now you can fire up MySQL, you can go in there, you can query it, you can extract whatever you need out of it. Don't circumvent that by creating clones for backups. One of the nice things about snapshots is they are read-only. Somebody might say, well, hey, why do we want to bother going and doing all this effort by creating clones of snaps? Let's just create clones for backups instead of snaps. The problem is if you do that, somebody could modify them. You don't want to mess with the integrity of your backups. You want to know they're read-only and nobody can touch them. I think we lost something there. Thanks.
It's going to change the model.
Yeah.
Does that also take a short time? Is it making a clone also an intent?
Yep, exactly. And the thing is, if you're creating a clone of a snapshot, you don't have to quiesce. You don't have to do all that. That's already been done. Your snapshot, your backup, it's not changing. It's already static. So you don't have to worry about the whole quiesce thing. I mean, literally, I have a process that does this, and it's completely automated. So the whole thing from basically, you kick the process off, it lists every single backup that we have available, and you just tell it which one you want, and literally in under 5-10 seconds, boom, database is up and online. You don't have to do anything. You can immediately go in and query it and see whatever you want. Pretty valuable too if you're trying to do some granular recovery or even just research. You wanted to find the state of something at an earlier point in time. You could just sequentially go through all your backups and keep going back in time and find out, well, when did this change? So, oh, you're jumping ahead a little bit.
Yeah, I'm just checking all of them.
If you hold on granular, yeah, let me just see what the next thing was. Okay, so we were talking about a dedicated host, and perfect. Okay, so if you have a dedicated host and you need to do very granular recovery, like you need to recover an individual record, the great thing is you've got this other host. You've basically got a view into your backup. You can use MySQL Dump to extract the individual records that you need. It could be one record, it could be hundreds, thousands, whatever it is. What you could then do, and very powerful with MySQL Dump, is using the W switch, which basically allows you to add a where clause. So what you can do is, for example, if you know the primary key or whatever it is, this is what you need to extract. You throw that in your where clause, take the output. What you can do is pipe that to sed, convert your insert to replace. If it's only one row, you could also do it manually. Just make sure that you are not extracting DDL. You only want DML. You don't want to go blow your tables away. But once you've got that, take that, literally you have the DML, go back over to your production system and dump it back in. And now what you can do is automate right back. You could, if you wanted to, you could build an entire level of automation over this. You could build some tools that allow some of your users, if they need the ability to recover very granular data, you could create a tool where they just literally punch in when, what, and it does the whole thing for you. So that's very granular. That's down to the row level. What if you need to recover an individual table? With MySAM, it's kind of easy. Literally just copy the 3 files, rename those 3 files, take them back to your production system, drop them in place. And again, if you've renamed them and those names are not conflicting with anything else, well, nothing's querying them because it doesn't know they exist. And then if you use the rename table statement, you can atomically swap them out by swapping the 2 tables in one statement. In ODB, you could do it with a similar approach. It's just you have an extra step. You have to use like a MySQL dump. You can't copy the individual files. But using this process, you can restore at the table level or the row level, or using the other thing we just talked about, you could roll everything back. When you think about the frequency of any of these events, the frequency that you have to do a full-blown restore from backup for your entire database is, generally speaking, should be pretty rare. You shouldn't have to do that very often. Very granular recovery is probably going to be more often. That's something that you may have to do once a week, once a month. It just totally depends on your application. But being able to have access to your backups will be extremely valuable. One of the things to think about as we're talking about creating backups as snapshots, you should think about retention. So I believe NetApp limits the number of snapshots you can take to 255. Other SANs may be higher, lower. When you think about it, 255 is a lot of backups. That's a lot of snapshots. It's pretty unlikely that you really need that many. So what I would suggest is think about retention and put together a retention policy, whether you want to just store 10 days worth of data, do you want to store 7 days, 7 dailies, multiple weeklies, monthlies, whatever the retention policy is. Think about what that would be, and you could build a process to manage your retention for you. We were just talking about disks before and whatnot. One of the things you should think about is moving archive backups to another medium. All of these snapshots will consume I/O. Now, granted, it's going to be much more efficient on any means of enterprise storage than what you'll have using traditional LVM, but there is still an I/O, little bit of I/O overhead by holding that snapshot around, especially the older that snapshot is, because remember how it works. The older the backup is, or the snapshot, the more it's going to grow over time. So think about taking archive snapshots that you may keep for the sole purpose of archiving, but you would never actually roll back to. Like, let's just say that for legal purposes or historical purposes, you need to keep 6 months worth of backups. Are you ever going to restore to the backup from 6 months ago? Probably not. So think about moving that off to another medium to get it out of there. We said the disk usage grows and the I/O overhead also grows. I want to talk about replication a little bit, because with replication, again, when I've worked with replication and I've used attached storage, if you have a slave that dies for whatever reason, slave fails, you need to resync that slave to a master. There are some fancy tools that you can use to try to do a resync, but let's just say that slave is completely gone, total failure of all the disks, or you're building a new slave that you need to add. The way I've had to do this in the past when using locally attached storage is by literally taking another slave out of the pool, rsyncing all the data over to the other machine, putting them both, firing MySQL back up in both of them, letting them both catch up in replication, and then putting them both in. I've done this in the past, and it's taken literally, I can remember times that it took 24 hours to actually get all this data over and not only copy the data, but get it caught back up in replication, because for all the time that it's copying the data, now you're falling behind in replication. So very time consuming. One of the really cool things, and one of the coolest things about using enterprise storage for MySQL is we talked about a clone as a writable snapshot. One of the coolest things to do is take your MySQL instances, your slaves, and actually run them on a clone. So they don't have their own dedicated disks. They're actually sharing disks. I think that's my next bullet point here. Oh, I'm skipping ahead. They're actually sharing disks and individual blocks. So basically what this means is, if you have 3 slaves, you have a master and 3 slaves, we talked about that aggregate. In the NetApp world, it's called an aggregate. We're sharing the same disks underneath from the master and the slave. This may sound a little crazy. Why would you want to do that? Well, actually, generally speaking, you'll actually see a performance benefit from doing this, because if you think about it, your slaves are probably sitting behind some sort of a load balancer, and your application is probably sending the same types of queries to all of your slaves, right? Of course, the queries aren't going to be identical, but maybe some of the values in your where clause will change. But you're hitting the same type of tables. It's the same type of queries that are hitting it. By sharing the same blocks, your storage is able to hold that cache and stop going back to disk for the same stuff. So if your slave 1 gets executed, it receives a query, it has to go down to disk, grab this stuff. Well, your storage system, it's going to cache that stuff. And then when the other slaves goes to query it, you don't have to go all the way back down to disk. So you'll probably get a little bit of a performance boost based on that. We're sharing the same disks, and we're actually sharing the same blocks as well. So we said running the slaves as a clone of the master. We share the blocks. We share blocks on the master and slaves. One of the other nice things about this is it allows us to add slaves quickly, right? If you don't have to copy all your data, let's just say that whatever the event is, you need to add capacity, you need another slave, and you need to quit. You could use this process. You could create another clone, and start up and fire up another slave very quickly. The other thing that is extremely nice about this is the ability, when you run your slaves on clones of the parent master volume, you can remove the need for resync tools. I don't know, for anybody who runs replication, have you ever had problems where your slaves go out of sync? I would imagine anybody who does has had that problem. Well, there's a whole bunch of fancy tools out there that will allow you, they will try to resync your slaves for you. They'll connect to your master, they'll connect to your slave, they'll try to figure out what the differences are, and they'll try to rerun those transactions. They're not really transactions, it's just looking at the differences. When you run your slaves on a clone, you could take all those tools and you could throw them away because you don't need them anymore. Basically, if you suspect that your slave is out of sync of your master, throw it out. Throw it out and resync it. It doesn't matter. You don't even have to waste time trying to figure out what the differences are, unless, of course, you want to try to fix the reason why it's happening. But
By resync, you mean shut down the replicant, snapshot your file system, make it a clone.
exactly, right here. So if you want to resync, or actually we shouldn't really call it resync.
Yeah.
We should call it reclone.
Yeah.
So if you want to rebuild one of your slaves, basically what you do, and again, if you have if you have a slave, we're going to assume you have a few slaves and they're in a pool. So you want to pull your slave out of the pool, so stop all the connections to it, and it will stop receiving traffic. Pull it out, and basically what you're going to do is shut it down. You destroy that volume, reclone the volume, and fire it back up. Now, again, you're going to want to make some changes, and this will change depending upon the file system architecture you pick. We talked about whether you put your binary logs in the same place or whether you separate them. If you put your binary logs in the same place, it could make this somewhat easier because you could look and you see what the most recent binary log is, and then you could parse that binary log and find the most recent position. Because the slave, if you just copy the master, or not copy, if you just clone the master volume and fire up the slave thinks it's a master. It doesn't know it's in replication. So you need a secondary part of this to put the slave back in replication at the point at which you clone the volume. So we were just talking about this. When you create a clone, depending upon the frequency of your backups, right? If you back up once a day, and let's say you back up at midnight, and it's 8 in the morning, and you create a clone, if you have a lot of transactions, you're going to have to wait 8 hours for it to catch up in replication if you create your clone off of a backup. So basically you have two options. When you're syncing your slaves, recloning your slaves, do you want to go off of the live master, or do you want to go off of a backup? Backup is easy because the database has already been quiesced, and you have a nice clean snapshot to go off of. If you want to clone off of the live master, you can't just fire off a clone. It's the same thing as a backup. You need to quiesce it first. So you want to take the same basic logic that you applied when you're creating your backup, your snapshot, and use that for your clone process to slow the master down. One of the things you may want to consider is the urgency when you're doing this, depending upon what your load looks like on the server, the way your backups behave. If you're just doing routine maintenance and you want to do a reclone, can you wait? Do you need to do it right now? If you are recovering from a backup, you're probably going to want to do it pretty quick. So if you're recovering your master to a backup, your slaves are out of sync, you're going to want to reclone off of the master very quickly. So you probably want to go right for it. I think I need your help one more time. So we just said it removes the need for any resync tools. Let me see if I can see what the next thing is here. Your reclone process should be automated. It'd be kind of a pain if every time you want to do a reclone, you had to manually stop MySQL and do all this stuff. You can script this whole thing. Literally script the perfect, thanks. You could script the whole thing. You want to make it very easy, so literally you just have one command that you have to run. The way I've done this before, you'll literally fire this process up. It gives you a menu, says, how do you want to do this? Do you want to go from the most recent backup? Do you want to go from the live master? Gives you a bunch of options. Another thing is, there's no need to back up your slaves. So if your slaves are disposable, and you're rebuilding your slaves on occasion from a clone off the master, why bother backing them up? So it makes life a little bit easier. You don't need to worry about backing those slaves up. Another thing is, keep in mind that, again, as these clones age, they grow. So if you're doing this and you're running your slaves on clones, you want to consider frequent reclones. It doesn't have to be every day. I usually like to do it once a month. Remember, the older those slaves get, as older those clones are, the larger they're going to get. So consider doing that periodically. Again, you have to reclone after a backup. One of the things that you may want to consider is if you have a lot of static or read-only data, and you're using MySQL replication, you may not even need it. So if you think about it, MySQL replication is not really very efficient for large volumes of static data. Let's just say that you have an application that you're using static data that comes in from a feed from some third party, whether it's say zip code data or movie listings or something that doesn't change very often, and it doesn't need to be very dynamic. Let's use zip code data as an example, right? Let's just say that you're processing this stuff periodically. You're probably getting it in the form of a CSV. You probably have some kind of a parser that literally looks at every single record in the CSV, converts that into an SQL statement, and fires it off to the database. If you think of regular replication, every single time one of these statements is being executed, the indexes have to be updated. Another big factor is if you're using MySQL's query cache, every single time that table is updated, any statements, any objects, result sets from a query that are sitting in the query cache that were based on the table, they're going to get evicted from the query cache. Even if that result set would not have changed, it's gone. So if you don't need your static data right away, you might want to consider having an offline machine that your application doesn't interface directly with. It's more for processing. It processes all your static content, and you just have a periodic reclone process to push it out. Another thing with replication is if you're running multiple MySQL instances and you have a DR facility, it's probably easier to deal with replication to your DR facility through your SAN than it is from each individual MySQL instance. In other words, if you have all these MySQL instances running, and each one is doing replication to a DR facility, you have more things that can go wrong. Individual MySQL clusters could break. I find it easier, I think it's easier, if you just let the SAN deal with all that. Saves you a lot of time. Of course, you could have issues with your data being atomic when you would transfer over, because all of your different MySQL instances are not synced with one another, right? So, one more time.
You just press the down button and load. They're just for some reason.
Oh, okay, thanks. Good. So one of the things that you might want to think about doing is monitor for your most recent backup, right? There's things that could go wrong. Something could break. Last thing that you want to happen is think your backup job is working beautifully, and then 2 months later, find out you need to revert to a backup, and you haven't taken a backup in a month, right? It would look pretty bad. So one of the things that I would recommend doing is set up a monitoring job that literally just checks the most recent backup. That's it. If you're, or most recent backup within X number of hours, whether you're doing dailies, you want to work for 24, 25 hours, whatever the case may be, set up a monitoring job. So if your backup job fails, you know about it, you can deal with it. Another thing that you may want to consider is an automated recovery testing host. We're talking about dirty backups that you can't actually recover from. So in the same way that we talked about a recovery host for very granular data, you could take that exact same concept and build another host that is 100% automated. You don't use it for any data recovery. It does it on its own. And literally whatever your backup frequency is, it's mounting up and creating these clones, these restores from your backups, and it's firing them up and it's checking to see, can we actually start the database, does it work? So if you have a problem, you can have that notify you.
Yeah, you could do other integrity checks as well.
Exactly. You could put all that work there. If you got a problem, now you know about it. You could also use that to find problems in your backup job. If you have too much sleep time here, if you need to tweak it, you can use that to adjust it. Same thing, monitoring for backup quality. We just talked about whether or not it's recoverable. You might want to also monitor for dirty backups. For example, we talked about when quiescing the database, if the lock monitor has to go and kill that lock, well, you could write that to a log file and basically say, hey, I had to kill the lock, here's a timestamp. So at least you know this is happening and you can tune and adjust accordingly. Another thing that you may want to think about is if you're doing a lot of data warehousing and you have ETL jobs that are going into your transactional system and copying a lot of data out, that's going to create some overhead. You may want to consider taking your backups, putting them to work, do the exact same thing, create another host that fires up however often your ETL jobs are running, if it's once a day, whatever the case may be. Have another host that fires up these backups and do all your ETL jobs there. This way it keeps them off of the transactional system. Yes, you're still hitting those underlying disks and still reading off of them, but your primary database instance isn't doing the work. You've offloaded all of that.
ETL stands for?
Extract, transform, load. For data warehousing, you want to go in, get the data, and bring it to an analytical environment. And that's it. Questions, thoughts, anything?
pages.
Uh-huh.
What, is that a separate piece?
So if you wanted to monitor, in other words, for a dirty backup, like in other words, if we talked about the lock monitor that has to go and kill. Is that what you're talking about?
Yeah, the lock, okay, so
Okay.
is that a separate process?
What I've done is I've basically created a shell script that would go and it's basically just backgrounding a job. That's really all the lock monitor would be. It's backgrounding it, and that is a separate script, and literally all it does is goes to sleep. At first it goes to sleep. When it wakes up, then it goes through, checks that we have a log, jumps in and tries to kill it. Does that answer your question?
Okay, so there's a SQL command to check for locks, I guess.
No, but what it does, it actually looks at the process list.
Oh,
Right? So we're issuing a flush tables with read log, and if that lock has not been fulfilled yet, and you look at the process list, you will see that it's still sitting in the process list.
Okay.
Does that help?
And this is a process list, the regular PS?
No, in MySQL, show process list.
Show process list.
Yeah, so you could actually see, is that still running? And then if you wanted to monitor for dirty backups, then what you could do is take that lock monitor, and if it is going to kill, or if it determines it does a kill, write it to a log file. You could build a monitor that literally just scrapes the log file, and if there's any events, shoots you a note. Yeah.
Well, you go first.
Lately, we've been having some performance issue with the NetApp writes, specifically. We've been using NetApp for several years, and lately it's been getting slower and slower in terms of taking a MySQL dump has been okay, but when we're trying to import into a NetApp-based MySQL, it's been taking a long time. For example, I'm trying to load, say, a 5 gigabyte file, and it takes more than an hour.
So, I mean, that's definitely a long time, and I'm not a storage engineer. There's a lot of things. I mean, that's something you might want to talk to NetApp about, but I have one question to start with. Those disks that you're running your database on, are they shared with other components of your application? That's one thing you might want to look
Sharing
at.
with other VMs, web servers, and things like that. So we may be
Yeah.
overloading the NetApp. But my system admins looked at the monitors. So it's not doing too much writes and read activity. It's doing a lot of waiting somewhere. Maybe it's related to network interrupts or something like that.
Yeah, I mean, there's so many things that could be causing the issue. It's kind of tough to say, but if it was me, let me put it this way. If somebody tries to put non-databases on some of my database volumes, or I shouldn't say volumes, somebody tries to put non-database disk activity on some of my database aggregates, I get a little annoyed and will put up a stink about that and get them out of there. They have no business being there. Yeah.
Have you run into fragmentation issues with NetApp's file? Now, maybe that happens behind the scenes.
Yeah, I haven't. I know that NetApp does things. They call it a waffle system,
Yeah.
right anywhere file layout. I believe that's what it stands for.
Yeah, yeah.
So,
But that still can get fragmented over time.
yeah, I just don't know enough about that side of things to really be able to answer that.
Yeah. And the other thing is, have you looked at the ZFS on Linux project? Because I know you're into the more, hey, write out to this appliance out here, and it gets all the good support and stuff.
So are you saying that so you have the snapshot ability in the file system?
Yeah, and it also integrates, you also didn't really mention SSDs, but that's kind of revolution in this
So again,
storage scene.
yeah, exactly. So again, if you could do that, but that kind of takes you back to using locally attached storage. And if you're running slaves, right? If you're running something like that, you're taking snapshots for backups on your database server with attached storage, you don't get the benefit of being able to run the slaves and the clones, unless of course you want to run them on that same.
You could take a general purpose, or you can use enterprise class storage hardware and make that the file server. So that having the ZFS under the hood gives you
Exactly. It's
more
basically the same.
snapshots, integrate, behind the scenes integration. I'm sure maybe now
Yeah.
I haven't really thought
And I
about
think we're saying the same thing. Where basically I'm saying, I've done a lot of this with NetApp, but you could apply this to any enterprise storage.
Yeah.
Basically, what you're saying is just kind of make your own.
Right.
But yeah, it's the same kind of
And
thing.
they don't charge you extra to mirror it to another system.
You'd have to be on Solaris, right?
No. There's a project called ZFS on Linux,
Oh,
and that's kernel mode ZFS. It's probably not ready for databases directly. That's kind of why I was asking. Well, probably within the next year or so, you'll see more people using that that software.
Mhm.
And there are also open source variants, forks from Solaris as well, so.
Okay, any other questions? Awesome, this was really interesting stuff. Are you
Great.
going to be able to give us the slides?
Yeah, I could send
So
it
we'll
to you.
share it on the meetup and if you
Yeah, that Quiesce slide is the money slide.
Great.